is the SOHCAHTOA. It makes remembering the angles and sides much easier. So if you know this, it will make life a whole lot easier. Now, SOHCAHTOA, let's look at the first part, SOH. That S refers to sine of any angle. Let's denote our angle theta. So that S is with reference to sine. Now the O is then with reference to opposite, whereas our H references hypotenuse. So if you are able to remember SOHCAHTOA, you automatically know the S is for sine, the O is for opposite, and the H is for hypotenuse. Now, if we look at the next one, we've got CAH. That C is with reference to cos. So if we have cos of a particular angle is equal to the A, which represents our adjacent side, and the H, which represents our hypotenuse. From there, we've got TOA, T-O-A, whereby the T represents tan, the O represents opposite, and the A represents adjacent. So those three are extremely important. SOHCAHTOA. In addition to those three, you have another three, which are the reciprocals of the above. A reciprocal is just to flip it over or to put one over an item. Now, the reciprocal of sine is cosec. So this is then going to be cosec theta equals. Now, when we're dealing with cosec, always remember it's the opposite or the flipped version of the original. So if you want to find cosec theta, all you need to do is flip sine, okay? So keep in mind cosec is equal to 1 over sine theta. And that is then equal to the hypotenuse over the opposite. We've got sec, which is the reciprocal of cos, and that is 1 over cos theta, which is equal to the hypotenuse over the adjacent. And with tan, the reciprocal of tan is cot. Cot theta is equal to, now when we are dealing with cot of theta, keep in mind that cot theta, that is the reciprocal of tan theta. So it's going to be 1 over tan theta, which is then equal to our adjacent over our opposite, okay? So those are the 6 identities that are very important. You need to be able to remember this. I would recommend memorizing the first 3. If you are able to memorize the first 3, finding the reciprocal will be much easier. You will not struggle to find the reciprocal, okay? Now, one more thing that we are going to do, well, actually 2 more items that we are going to complete before we get to a past paper question is Pythagoras, how to label the angles, or rather how to label the sides of a triangle, and our cast diagram. So we're going to complete those 2 items before we get a chance to move on to our past papers, okay? So let's say, for example, I have this particular triangle. Now keep in mind, this is going to be a right-angled triangle. Now, a right-angled triangle always has an angle of 90 degrees. That is what the square in the corner represents. It represents an angle of 90 degrees. Now, if this side is, let's make it theta. Okay, so this is our angle that we are referring to, or the angle that we are going to use as a reference point. Now, let us call this R, let us call this X, and we can call this Y, okay? Now, something that is very important to take note of before we actually get to the trigonometry part of this is the Pythagoras part. So how do we use Pythagoras on a 90-degree triangle? Always keep in mind, Pythagoras is as follows. It's always going to be the hypotenuse squared equals the adjacent squared plus the opposite squared. Now, from this, you can then produce two other formulas. This formula is used to calculate R. If you rearrange your variables, you can calculate for X or Y. It doesn't matter. As long as you know the first part, you can rearrange the equation to calculate what you need to. So if we were to rearrange this equation, let's have the first one. If we want to calculate for R. If we want to calculate for R, all you are going to do is square root both sides. So that is then going to be x squared plus y squared all under a square root sign. If you want to calculate for x squared, you're going to end up, or rather, let's say if you want to calculate for x, you're going to end up with the square root of x, or rather x equals the square root, and under that square root you'll have r squared minus y squared. Okay, now that is how we would calculate for x. All you need to do is move y squared to the other side. It will then become minus y squared. From that point you square root both sides, and that will isolate or give you your x variable only. Now the third one that we will solve for will be y. Now, if we want to solve for y, all you need to do is take x squared to the other side. After you take x squared to the other side, you will then square root both sides. That is how you get rid of the squared on top of y. If you want to get rid of a squared or a cubed, you would just square root or cube root, okay? So that will then be the square root of r squared minus x squared. So those are the three formulas or the three equations that can be obtained once you simplify and solve or isolate a specific variable within Pythagoras' theorem. Okay, that is important to be able to understand and to use the theorem or to use the equation. You'll use it quite frequently within trigonometry. Okay, now next, let's have a look at how do we label our sides of our triangle. How do we know which is going to be the opposite, which is going to be the hypotenuse, and which is going to be the adjacent? Now let us first start with the hypotenuse. The hypotenuse is always going to be the side opposite the 90-degree symbol. So all you need to do is go and put a little dot on the corner of that 90-degree symbol. The one that's opposite that is going to be your hypotenuse. So in this particular case, our R will be known as our hypotenuse. Okay, so I'll repeat that once more. How do we find our hypotenuse? All you need to do is go to your 90-degree symbol and draw an arrow opposite that. That arrow is going to point to the hypotenuse side. Now, the opposite side gets its name from the fact that it is opposite theta, okay? Now, if we look at theta, draw an arrow from theta to the side that is opposite theta, and that is going to give us the opposite. So the side that is opposite theta is known as the opposite. Now, the side that's left over, that is going to be your adjacent side. Or if you want to find your adjacent side first, always know that the adjacent side is the side that is under theta. So let's make a note of this. Where do we find our hypotenuse? Our hypotenuse is opposite the 90-degree angle. How do we find our opposite? Our opposite is the side opposite theta. How do we find our adjacent? Our adjacent is the side under theta. So always keep that in mind. How do you find your opposite? Your opposite is the side opposite the 90-degree sign. How do you find the opposite? That is the one opposite theta. How do you find the adjacent? That is the side under theta. Okay, so keep that in mind. That is extremely important. Now, the last item of business that we'll get to is our cost diagram. Now, in our cost diagram, it's going to become extremely important for you to memorize this or to learn how to use it. You're going to use it from now until grade 12. A lot of students in grade 12 struggle with trigonometry because they do not know the cost diagram. If you know how to use the cost diagram, you're going to make life extremely easy for yourself. Okay, so my advice is to learn the cost diagram. Okay, now our cost diagram is split up into 4 quadrants. So we'll get to that in a moment. Okay, so your cost diagram is split up into 4 quadrants. You've got from 90 degrees until, or rather from 0 degrees until 90 degrees. This forms quadrant 1. You then have from 90 degrees until 180 degrees. This forms quadrant 2. Next, you have from 180 degrees until 270 degrees. This forms quadrant 3. And finally, from 270 degrees until 360 degrees, you have quadrant 4. So you only have 4 quadrants. From 0 to 90 is quadrant 1. From 90 to 180 is quadrant 2. From 180 to 270 is quadrant 3. And from 270 to 360 forms quadrant 4. Now, within your quadrants, you've got something known as cost. C-A-S-T. What does that mean? A represents all, C represents costs, S represents sine, and T represents tan. The letter that is there represents the identity that is positive. So if you were dealing with A, let's look at quadrant 1, whereby we have A. A represents all, meaning that sine, cos, and tan, all of the identities are positive within that quadrant. Keep in mind that greater than 0 just means positive, okay? So within quadrant 1, we have all of our identities as positive. Within quadrant 2, that S means only sine is positive. So we have sine theta greater than 0. We'll have cos theta less than 0 and tan theta less than 0. Sine is positive, cos is negative, and tan is negative. So the letter that is within the cost diagram represents the identity that is positive within that quadrant. If we move on to quadrant 3, you can see that there's a T there. That means that only tan is positive. So we have sine theta that will be less than 0 because it's negative. Cos theta that will be less than 0 because it's negative. And we have tan theta that will be the only one greater than 0 because it is positive. So always use the letter to understand which identity is positive or negative within that specific quadrant. Now keep in mind you are not going to get this in an exam. All the information that I've written, so if we go back a bit, all this information that I've written down, you need to know this by head. This information is not going to be given to you in an exam. You have to know this information, okay? So let us go and finish up our last quadrant. Now, lastly, we have quadrant 4 that is from 270 degrees until 360 degrees. Now, within quadrant 4, you can see that we've got the letter C. That letter C represents cos positive. So only cos is positive within quadrant 4. So keep that in mind. Okay, so that is our cost diagram. I'm going to zoom out for a moment. Anyone that has any questions or anything they'd like to ask, mention, or add on to the session, you are welcome to do so now. You can unmute yourself and you can speak up, or you can leave a message in the chat box and we will address it. So if you have a question, something you'd like to ask, something you're not sure of, you can ask now before we move on to the cost, or rather before we move on to the exam level questions. Goratile, you have your mic unmuted. Do you have a question?
Sir,
Yes, Umpile.
sir, can
Yes.
you prove that quadrant one is all the like is all positive? Can you please prove it?
Sorry, what did you say is opposite?
Like I mean, quadrant one. Can you prove that is all positive, and then quadrant two prove that they are all I mean
Oh, you want to
negative.
see how they become positive and negative.
Yes.
Okay, so how they become positive and negative is based on the triangle that we did previously. So before we get to that, you need to understand the triangle. If you look at that triangle that I've drawn, just give me a moment, please. Okay, so if you look at that triangle that I've drawn, right, that triangle is going to look different within each quadrant. The triangle that I've drawn up there only represents quadrant 1. If you were to flip that triangle, or if you were to reflect that triangle about the y-axis, you would then get the triangle in quadrant 2. If you were then to reflect that triangle in quadrant 2 about the x-axis, you'll get your triangle in quadrant 3. So all you're doing is basically flipping the triangle to get the next quadrant. So as long as you understand that triangle, proving them will be easy for you. All you need to understand is which is positive and which is negative. So let's have a look at that. So within quadrant 1, right? Within quadrant 1, we've stated that everything is positive. So let's prove it. So give me a second. Actually, instead of doing them individually, let's do them all together. So this is going to be quadrant 1. We know that quadrant 1 is from 0 degrees to 90 degrees to 180 degrees to 270 degrees to 360 degrees. Now, give me a moment to draw a triangle in each. Okay, let's just handle it one quadrant at a time. So if you look at this, right, I'm sure you all are familiar with your axis. You've done axes already, right? You've got a positive axis, you've got a negative axis in both the x and the y direction. Now, on the right side, we're going to only look at our x-axis for now. The x-axis is the horizontal line that I've drawn if you are not sure what an x-axis is. That's the x-axis. Now, our x-axis has positive x values on the right and negative x values on the left. So this is now going to be considered positive x, and this side will be considered negative x. Now, let us now look at our y-axis. That is the vertical line that I'm highlighting. This is known as your y-axis. Now, within your y-axis, you've got the top, which is positive, and the bottom, which is negative. So this is going to be positive y. This is going to be negative y. Now, if you look at the positive and negative values that I've drawn, you can see that based on your triangle, this is the height, which would represent y. So you can see that that has a positive y value. And always remember that your hypotenuse is always positive. You can't have a negative hypotenuse, okay? Now, let's make our angle theta over here. So if we were to prove sine theta, so sine theta is going to be opposite, which is positive y, over hypotenuse, which is r. As you can see, you get a positive value from that. If you take a positive value divided by another positive value, you will end up with a positive resultant or a positive answer. Now let's have a look at cos. So if you have cos theta is equal to, we know that cos theta is equal to the adjacent, which in this particular case is x, over the hypotenuse. So as you can see, we now have a positive value divided by another positive value. That is going to leave us with a positive answer. Now, lastly, we have tan. Let's have a look at tan. So tan of theta is going to be equal to opposite, which is positive y, over adjacent, which is positive x. And a positive divided by positive is going to give you a positive. So that is proof that within quadrant 1, everything is positive. Always remember that. The whole thing is just based on what side of the triangle you are on. Now let's have a look at quadrant 2. Now within quadrant 2, let us just draw another triangle. Now, as you can see, this once again is your height, so that will be your y value. But the only difference, if you notice, between quadrant 1 and quadrant 2 is the x values. As you can see, on the right within quadrant 1, x is positive. On the left within quadrant 2, x is negative. So let us prove that only sine is going to be positive within quadrant 2. So we've got sine of theta is equal to opposite, which is positive y, over hypotenuse, which is r. A positive y divided by a positive r will give you a positive answer. Next, we have cos theta. So as you can see from our answer of sine, we have proved that sine is in fact positive, okay? Next, we have cos. Now keep in mind, cos is adjacent over hypotenuse. Adjacent is our x value and hypotenuse is our r value. So adjacent, which is negative x over positive r, that is going to give you a negative value. If you divide a negative number by a positive number, you are going to get a negative answer. Look at this, for example. If you have negative 2 divided by, let's make it 4, that is going to give you negative 1 over 2. So your answer is in fact negative. But if you have positive 2 divided by positive 4, you will end up with positive 1 over 2. So depending on what signs you have within the original question, your answer would match. So if you have negative divided by positive, you'll have a negative. If you have positive divided by positive, you'll have a positive, okay? Now, there's also an additional case whereby you can have negative divided by negative. That will give you positive. The reason being is what you've learned from grade 8, your multiplication and addition and division of signs. So if you have a positive sign times a positive sign, that is going to give you a positive. If you have negative times negative, that will give you a positive. If you have positive times negative, that is going to give you a negative. And if you have negative times positive, that is going to give you a negative. The exact same thing works for division as well. So if you have a negative, or rather a positive divided by a positive, you'll end up with a positive answer. If you have a negative divided by a negative, you'll end up with a positive answer. If you have positive divided by negative, you'll end up with a negative answer. And lastly, if you have a negative divided by a positive, you'll end up with a negative. If you can't remember all of this, an easy way to look at it is, if you notice, the same signs always give you positive. And when there's different signs, it gives you negative. So same, positive, different, negative. Think of it like that. When you add or divide the same signs, you get a positive value. When you multiply or divide the same signs, you get a positive value. When you multiply or divide different signs, you get a negative value, okay? Now, let us quickly prove the last two so that we can get started with some past paper questions. Now, let's have our triangle in the third quadrant. So once again, this is going to be a right-angled triangle. We'll have our angle over here, and let's see, we've got negative x. This is going to be positive r. Now, as you can see, the height, this is the y value of the triangle. You can see that it's negative within this quadrant. So our y value is now going to be negative y. So let us prove. So if we are proving for quadrant 2, or rather quadrant 3, let's see, we've got sine theta is equal to, now our opposite, which is y, over our hypotenuse, which is r. As you can see, we have a negative value divided by a positive value. That is going to give us negative. Next, we have cos theta. Cos theta is equal to the adjacent over the hypotenuse. So negative divided by positive. And that is going to give us a negative value. Now, lastly, we have tan theta. Now, keep in mind, we previously mentioned that tan theta is positive within the third quadrant. So let us prove that. Tan theta is equal to opposite, which is negative y, over adjacent, which is negative x. So negative y over negative x, if you have negative divided by negative, that is going to give you a positive. Now, lastly, within our fourth quadrant, we've got our last triangle that we are going to use. This is going to be r, this is going to be minus y, and we have a positive adjacent in this case. So let us prove quadrant 4. Now, here we're starting with sine of theta equals our opposite, which is negative y, over our hypotenuse. So that is going to be minus y over r. That gives us a minus. Next, we have cos theta is equal to, cos theta is adjacent over hypotenuse. So that is going to be positive x, or yeah, positive x over r, and that is going to give us a positive value. Lastly, we have tan theta. Keep in mind, tan theta is going to be negative within the fourth quadrant. Tan theta is opposite over adjacent. So you have negative y over positive x, and that gives you a negative answer. Now let us compare both quadrants to their proof. Now, if you have a look, we previously mentioned that our first quadrant, everything's going to be positive. As you can see, positive, positive, positive. So that was true. Everything is positive within the first quadrant. Now, our second quadrant, we have only sine positive. As you can see, only sine was positive, whereas cos and where's tan? Okay, we didn't do tan for the second quadrant. Let's do that quickly. So tan for the second quadrant is going to be opposite, which is positive y over negative x, and that will give you a negative answer. So as you can see, only sine was positive within the second quadrant. If you look at the third quadrant, we said only tan is going to be positive. There's the proof. If you look at the fourth quadrant, we said only cos is going to be positive, and there is the proof. So we've now proved our previous statement. So I'm going to zoom out one more time. If you have any questions, you're more than welcome to have a look at the whole picture to see if there's anything you don't understand. If you don't understand something, you're welcome to unmute yourself and speak up, and we will address it before moving on to the past paper questions. Okay, so it seems like no one has any questions, so let us move on. Now, our first question, let's have a look. So we have question 4. This is from a November exam. We've got question 4. There was a student that put your hand up. Do you have a question? Okay, there's 2. Amalia and Cornele, you've got your hand up. Do you have a question?
Can you please zoom the paper?
Yes, what's your question?
Can you please zoom?
I can't hear you. You want me to zoom in or out?
In.
In. Like this?
Yes, there.
Okay. Do you have a question or you just couldn't see? Okay. Then Cornelia, you've got your hand up. Do you have a question? Okay, so let us proceed then. Okay, so this is question 4 from a November exam. We've got a right-angled triangle, has sides A, B, and C, and an angle theta. So if you look at our triangle, with reference to the position of theta, B is going to be your adjacent, A is going to be your opposite, and C is going to be your hypotenuse. Now, we've got question 1 that states, write the following in terms of A, B, and C. So we need to write the value of cos theta, tan theta, and sine 90 minus theta in terms of A, B, and C. So before we do that, I know sometimes it can be a bit difficult when your triangle is not straight up or it's not flat, if it's upside down or if it's sideways. So if it's slanted, it might sometimes be difficult for you to understand which side is the adjacent, which side is the opposite, and which side is the hypotenuse. So before we get started with this question, let us first draw our triangle. So this is our triangle. We've got our 90-degree sine. We've got B at the bottom, A here, C here, and we've got theta. Now, before we proceed with this, the first thing that we are going to do is label each side. That is always the first thing that you do whenever you see a right-angled triangle and you need to get sine, cos, or tan. Step number 1, label the sides. So as you can see, C is the side opposite the 90-degree sine. Therefore, this is going to be our hypotenuse. A is the side opposite theta, therefore that is going to be our opposite. And the side under theta, which is B, that is going to be our adjacent side. Now, let us have a look at question 4.1a. So question A, write down the following in terms of A, B, and C. We need to write down what is cos theta equal to. So in order for us to find cos theta, we need to know our SOHCAHTOA, right? So SOHCAHTOA. Now we are dealing with cos, so we're going to look at CAH. We can see that it's C for cos, A for adjacent, H for hypotenuse. So our cos theta is going to be equal to the adjacent over the hypotenuse. And what is our adjacent value? Our adjacent value is B, whereas our hypotenuse value is C, and that is our answer. Just like that, we end it there. We're not going to add anything else. We can't simplify any further. That's it. We stop there. Now let's have a look at the next one. We've got B. Now B is tan theta. So if you have a look at tan theta, you can see that tan theta is TOA. T for tan, O for opposite, A for adjacent. So that is going to be opposite over adjacent. Now our opposite, let's have a look. Our opposite is A and our adjacent is B. So we stop there, we don't go any further. Now, I would highly recommend you label the sides of your triangle before you get started. As you can see, it made life so much easier for us when we were finding A and B. All we needed to do was extract the values from our triangle, whereas if you didn't label the sides, if you're in an exam, it can sometimes be stressful, you're in a rush. You can sometimes mix up your values or make a mistake. So always label the triangle, it makes life easier. All we are now doing is copying from the triangle. We're not thinking, we're not doing any extra work. All we do is we see adjacent next to B, so we extract B. We see opposite next to A, we use A. All you need to do is look what you've written, take that value. There's no additional thinking involved, okay? Now, let's have a look at C. Now, C looks slightly different as compared to the other two that we dealt with. If you look at C, we've got 90 minus theta. So how do we get 90 minus theta? Because our angle is theta, it's not 90 minus theta, right? So how do we now find 90 minus theta? Always keep in mind that this is a triangle. A triangle has all three interior sides equal to 180. So let us try and find this angle. You'll notice that this angle is going to be 90 minus theta. So let's just call it angle. So we've got our rule that states theta plus 90 plus, we'll call it angle, equals 180. And our reason is sum of interior angles of triangle equals 180. From there, we can proceed to simplify. So we're going to take everything that is not the angle to the other side, because keep in mind, we want to solve for the angle only. That's what we need to try and solve for. So we're going to take everything to the other side. So it's going to be 180 minus 90 minus theta. So we know that 180 minus 90 is going to give us 90 minus theta. And that is the proof that we were referring to this angle over here. So always remember 90 minus theta is just the third angle of a triangle, more specifically a right angled triangle. Now, because we are using a 90 minus theta as our reference point, our adjacent and our opposite are now going to change because we're standing in a new position. Pretend as though if you are standing at theta, your opposite and your adjacent would be different, right? As opposed to if you were standing at 90 minus theta, you have different viewpoints. You are able to see different sides of the triangle. So let us now label our new sides. So first step, do you see that the hypotenuse has not changed? It's still opposite the 90-degree sign. So this will remain as hypotenuse. Now 90 minus theta, the opposite to 90 minus theta is B. So we're going to now label this opposite. And under the side under 90 minus theta, that is going to be the new adjacent. So everything that's in blue, that was to assist you with question A and B. So let's make a quick dot here to show it's the blue. And everything that's in yellow, the hypotenuse, opposite and adjacent, that's in yellow, that is to assist you with question C. So our question is now sine of 90 minus theta. What is sine of 90 minus theta equal to? So think of sine. What is sine equal to? If you look at our top SOHCAHTOA, sine is equal to opposite over hypotenuse. Now, from there, what is our opposite and what is our hypotenuse? Now, our new opposite is B, and our hypotenuse, which has not changed, remains as C. Okay, so sine of 90 minus theta is equal to B over C. Something interesting to take note of. I don't think you've learned this as yet in grade 10. You will in grade 11 or 12. Now, if you notice, your cos theta was equal to B over C, and sine of 90 minus theta is equal to B over C as well. Why is that? The reason is that they are co-ratios, or some people like to call them co-functions. So an interesting note is that cos of 90 minus theta is equal to sine theta, and sine of 90 minus theta is equal to cos theta. Okay, so that's an interesting note to take note of. Now, let us move on. That was question 4.1 A, B, and C. Now, all we had to do for this particular question was identify which is the correct opposite, adjacent, and hypotenuse. Once we were able to do that, we then found cos and tan and even sine of 90 minus theta with reference to the particular angle that we were dealing with. So always remember, step number 1, label the sides of your triangle with reference to the angle that you are looking at. So if you were looking at, or if you were dealing with theta, label the sides with reference to that angle theta. If you were dealing with 90 minus theta, label the sides with reference to 90 minus theta. So be very careful with that. Don't confuse them. I would recommend using different colors if you need to. But yeah, all we needed to do, most important thing, was to identify the sides. As long as you understand how to identify sides, the workload is basically cut in half. All you're doing is you're just copying values after that. So let's move on to our next question. So next we have question 4.1.2, right? Now question 4.1.2 states, if it is given that A equals 5 and theta equals 50, calculate the numerical value of B. So let's make a note of the values we are now given. Then we can decide how do we proceed with this question. So we have 4.1.2. We were told that A equals 5 and theta equals 50 degrees. We need to find what is the value of B. So let us look at our identities, right? We have cos theta, we have tan theta, and we have sine of 90 minus theta. Out of those three, which can we use to find B? So the first step that you are going to do is identify out of the three which has B in it. You can't use an identity to find B if the identity doesn't have B in it, right? It's not going to make sense. Now let's have a look. So A cos theta equals B over C, that has B in it. B tan theta equals A over B, that has B in it. And sine 90 minus theta equals B over C, that has B in it. So now everything has B. Now let's see how else can we solve. Let's see A. We were told that A is 5. We don't have C, right? Because we don't have C, anything that has C in it, we cannot use it. So if you look at cos theta, it has C in it. We can't use cos theta. If you look at sine of 90 minus theta, it has C in it, so you can't use it. You can't use an identity that has C because we do not have the value of C. And we cannot use Pythagoras to find C because we have two unknown sides. You can only use Pythagoras in a single triangle if you have two sides known. You can calculate the third side. So if we look at B, tan theta equals A over B. We were told that theta is 50 degrees, so we have that value. We were told that A is 5, so we have that value. The only unknown is B. So we can now use tan theta equals A over B to solve for this particular question. So the main thing was to try and identify which identity can we use to solve this. You cannot use something that does not have B in it, because you cannot solve for B if you don't have B in the equation. You cannot use something that has C in it because we do not have the value of C. So let us start. So we're going to use tan theta equals A over B. We know that theta is 50 degrees and A is 5, B is unknown. We leave it as B. So that is now our new equation. All we now need to do is solve for the unknown, which is B. So from here, what can we do? We can't solve for B while it's in that position. So we now need to cross multiply. We know that tan theta or tan of 50 is just over 1, right? Anything that doesn't have a denominator, always remember it is just over 1. So we cross multiply. That is then going to become B times tan theta, which is going to be B tan of 50 degrees, and 1 times 5, that will remain 5. From here, we need to isolate for b. We need to get rid of anything that is not b. So all we do is we divide by what is not b, which in this particular case will be tan of 50. From here, we can see that tan 50 cancels tan 50, and we are then left with b equals 5 over tan of 50. Once you put 5 over tan of 50 into your calculator, you should end up with a value of 4,20. Now that is our value of b. All we needed to do was find the appropriate identity to use, substitute the value of a, which was given, substitute the value of theta, which was given to us, and then finally use our algebra rules to solve for b. Now that is question 4.1.1, A, B, and C, 4.1.2 complete. Move on to 4.2. I'm going to zoom out to allow you the opportunity to have a look at everything. Now, if there's anything from here that you do not understand, you are welcome to speak up, unmute yourself, and ask. So if there's any parts that you need me to repeat or anything that doesn't seem clear to you, something that seems a bit weird, you don't know how we got from step 1 to step 2, you are welcome to ask. Zenobia, you sorry if that's the incorrect pronunciation of your name. You had your mic unmuted. Do you have a question or something you want to ask?
How did you get to 1050?
How did I get to tan 50 from
Yes.
tan theta? Okay, so in the question, let's just give me a moment to go back to the question. So in our question, they've stated, question 4.1.2, if it is given that a equals 5 and theta equals 50. So that value of tan theta came from the question itself. So all we needed to do in order to find tan theta was to substitute that value of 50. Are you okay with that, Zenobia?
Yes, thank you. I understand.
Okay, perfect. Is there anyone else that has any questions, something that you're not sure of, something that you want to ask before we proceed? You're welcome to put your hand up or to unmute yourself and speak up. If you're a bit shy to speak up, you can always type it out in the chat box and we'll have a look at it there, okay? Okay, so let us proceed then if no one has any questions. So next we have question 4.3. Now question 4.2, not 4.3. So question 4.2 states, given that A equals 38.2 and B equals 146.4. So we are now given the values of angle A and angle B. Keep in mind that little copy, that little hat thing on top, that represents angles. So when you see an alphabet, when you see a variable that has that little copy, that little hat thing, always take note that they are referring to an angle. So in this particular case, they are referring to angle A and angle B. Okay, so let us proceed to read the question. It states that 4.2, given that A equals 38.2 degrees and B is equal to 146.4 degrees, we are given calculate the value of 2 cosec A plus cos 3B. So all we are now going to do is substitute the value of A into cosec A, and we are going to substitute the value of B into cos 3B. That's all we're going to do. From there, we can put it into our calculator and get a final answer. Now, one important step that we need to complete before we can actually substitute those values is to address cosec A. Now, cosec A is not something that's on our calculator. We don't have cosec, we don't have sec, and we don't have cot on our calculator. We have sine, cos, and tan. Now, how do we convert that cosec into sine, cos, or tan? We know that cosec is one of our reciprocals. Cosec is 1 over sine. So instead of putting cosec onto your calculator, because your calculator doesn't have cosec, you can put 1 over sine. Okay. Now, students that don't know what I'm talking about when I say you can put tan and sine and cos into your calculator, if you have a calculator, when I say calculator, I don't mean those ones that you use in primary school. I'm referring to the ones that you most likely bought when you got to high school. They come in multiple colors, I think blue, pink, black, white, whatever. It's those ones with all the different buttons and they've got A, B, C on there. They've got so many things. That's the calculator I'm referring to. If you look at that calculator, they've got a button for sine, they've got a button for cos, and they've got a button for tan, okay? That is the calculator that you are going to use. So let us now try to solve this particular question. So we've got 4.2. Let us make a note of the important information that we are given. So we are given, let's see, 4.2. We are told that A is equal to 38,2 and B is equal to 146,4 degrees. Now, from there, we need to substitute that into 2 cosec A cos 3B. So let's have a look at that. Now, our equation is 2 cosec A plus cos 3B. Now, from here, we know that cosec A is equal to 1 over sine A because it is a reciprocal. So 2 times 1 over sine of A plus cos 3B. From here, we can substitute what is the value of A. So A is given as 38,2 plus our value of B. Keep in mind it's 3B. So we now need to multiply that angle of B by 100, or rather by 3. So our angle of B is 146,4. Because we were told cos is cos of 3B, we now multiply the angle, which is B, by 3. Keep note of that, that is important. Now, from here, all you now need to do is put this entire thing onto your calculator. Something important that a lot of students struggle with. What you see on the page is not what they put into the calculator for some reason. Whatever is on your paper, put the exact same thing into your calculator. Don't change things because I have a 2 times 1. Don't go there and put 2 plus 1. It's not a plus sign, it's a minus sign. Whatever is on your paper, put the exact same thing into your calculator, okay? So once you put this into your calculator, you should then get 3,42. That should be the answer that pops up on your calculator. You can try this out now on your calculator if you are near one. You can put it into your calculator and see if you get 3.42. If you don't get 3.42, that means you put it into your calculator incorrectly. And if you did that, you're welcome to unmute yourself or pick your hand up and tell me that you didn't put it into the calculator correctly, and I can then show you or tell you what to put in so that you can understand what to do. There's no point in getting all the calculations right and then you get the final answer wrong. Makes no sense, right? So try to get as many marks as you can. 1 mark could be the difference between passing and failing, okay? So keep note of that. It's very important for you to learn how to use your calculator. Now, this is question 4.2. Let us move on to question 4.3. Now, question 4.3 states, simplify fully without the use of a calculator. Now, if you notice, they've stated or they've used 45 and 60. Now, when you see angles like 45 and 60, there's something that should click in your brain. Okay, I know these angles. These are familiar. These are your special angles. 45, 60, those are special angles. 30 is also another special angle. So whenever you see those special angles and they tell you do not use a calculator, please don't panic, because it is possible to find them without a calculator. You're already familiar with special angles. You just use those concepts. So let us have a look at that. I'll show you how do you find those special angles and where they come from. So let us start, let us find a space. Let us do it over here. Now this is question 4.3, right? So question 4.3, we were told to find sine of 45 times tan squared of 60 all over cos 45. Okay, so we need to find this. We need to simplify it without the use of a calculator. Now, how do we do that? We make use of our special angle triangles. So our special angle triangles, we've got our 45 by 45, and we've got a 60 by 31. So this is 90, this is 1, this is 1, and this is root 2. Now, all you need to remember is the 1 and the 1. You can find root 2 using Pythagoras, okay? So this is 45 degrees. This is also 45 degrees. If you're not sure what I'm referring to when I'm talking about special angled triangles, you can refer to your textbook. There are notes about it in there. Now, this is going to be our 60 and our 30 degree triangle. This is going to be 2, 1, this will be 90, and this will be the root of 3. Now, how we obtained that 60 by 30 was by originally having an equilateral triangle. An equilateral triangle is a triangle that has all equal sides and all equal angles. So an equilateral triangle has 60 all round. This will be 2, 2, and 2. Now, if you were to cut this equilateral triangle in half, you would then end up with what we have. So if you cut 2 in half, you'll have 1 on this side, 1 on this side. If you cut that 60 degree angle in half, you'll have 30 on this side, 30 on this side. And this will be 90 because you bisected it, you cut it in half. So that is how we obtained this 30 by 60 triangle, okay? That is important. Now, let us try to continue with our question. Before we do that, let me just move this to the side quickly. Okay, so we are going to use these triangles to now find what is sine of 45, tan of 60, and cos of 45. Now, if you don't want to use the triangles, or if you don't know how to use them, or if you forget them, you can always use your calculator. Even though they say don't use your calculator, no one's going to check. And the fact that you are allowed to bring the calculator into the exam venue means that the rule isn't that strict. So you can use your calculator if you want to. Your teacher can see if you use the calculator, she will or he will be able to see, but I doubt they would care that much, because I'll show you how they see. If you are dealing with, let's say, sine 45, right? So if we're now dealing with sine of 45. Sine of 45, if you use your triangles, you'll get 1 over the root of 2, right? If your teacher sees that, they'll know you didn't use a calculator. But if your teacher sees sine of 45 equals to root of 2 over 2, your teacher will know that you used the calculator. The reason being is that your calculator rationalizes the denominator. What that means is that if you have a surd in the denominator position, the calculator does not like surds in the denominator position, so it gets rid of that surd. If you want to convert it back so that it seems like you didn't use a calculator, all you need to do is multiply by the numerator, which is this root 2 over 2, and you'll go back to what you originally had. But I doubt your teacher is going to care that much whether you used one or you didn't. So yeah. Okay, give me a moment. I did see that there is a message in the chats. Before we continue, let me attend to that. Okay, give me a moment to just go to the chats. Okay, so it says, can the question get sent in the group? Yes, I will send the question and I'll send the solutions and I'll send a recording in the group. Okay, so everything that we're doing right now, you will also find it in the group. So yes. Okay, so let us continue then. So we now have sine of 45, tan squared of 60, and cos of 45. We need to simplify that using our special angles. Okay, so if we look at sine of 45, we've got two triangles. We've got one that's got 60 and 45 and 30. So we need to figure out which triangle are we going to use. Now, because we are dealing with 45, we're going to use the triangle that has 45. So this is my reference point. I'm going to stand here. Now, what is my opposite? This is going to be considered my opposite. Which is my hypotenuse? The one opposite the 90, that'll be my hypotenuse. So the leftover one, or the one under the 45, that is going to be my adjacent. So let us now fill in that information. We know that sine of 45 is just equal to our opposite over our hypotenuse. Now in this particular case, our opposite is 1 and our hypotenuse is the root of 2. So we've now completed sine 45. Let us move on to cos squared, or rather tan squared of 60. Now tan squared, you put the squared on the outside, you just need to find what is tan of 60. Now, because we're dealing with the 60, we'll use this bottom one here. Tan is opposite, so this is our opposite side. Then this is our hypotenuse. And this is the leftover side, so our adjacent. So tan is equal to opposite over adjacent. Our opposite is the root of 3, whereas our adjacent is 1. So that is what we have, the root of 3 over 1 all squared. The squared comes from tan squared, okay? If it was tan cubed or tan to the power 4, you would put that to the power 3 or to the power 4, whatever exponent, you would put it in, okay? Now, next we have cos of 45. Now, if we go to our first triangle, our 45-degree triangle, we can see that our cos of 45 is going to be equal to the adjacent, which is 1, over the hypotenuse, which is the root of 2. Now, if you notice, this top can cancel this bottom. And you are then left with the root of 3 squared, because the root of 3 over 1 is just the root of 3, right? Anything over 1 is itself. Now, the root of 3 squared is just going to give you 3. It's not going to give you 9, because keep in mind that the root and squared cancel each other out. It's like opposite inverses. Or if you were to do it the long way, you could square 3, that would give you 9, then square root it, that'll take you back to 3. Alternatively, if you wanted, you could have just put root 3 all squared into your calculator and you would have also ended up with 3. So that is our answer. In order for us to solve this question, the first thing that we needed to do was to draw our special angled triangles. Once we drew our special angled triangles, we were then able to extract the values that we needed based on the positions of those angles. Okay, that is very important. So all we needed to do was substitute the values and simplify. If you wanted to use your calculator, I would not recommend putting the entire thing into your calculator and then just writing a final answer. Number one being you will not get the full marks for it because the steps have marks. And number two, everyone will be able to see that you use the calculator automatically for that. So if you want to be smart and use a calculator, just put sine 45, write the value, put tan squared or put tan of 60, write the value, then put the squared outside. So if you want to use your calculator for this, I would recommend doing each component individually. Do not do it all at once because everyone will see that you used a calculator. So be careful with that. Always make sure that you do it individually or component by component, okay? Now, let us move over to the last, I think it'll be the last question, question 4.4. Let's have a look. Question 4.4. So with question 4.4, we have given that 5 cos of b minus 3 equals 0 and beta is within 0 to 90. If alpha plus beta is equal to 90 degrees and alpha is from 0 to 90, calculate the value of cot alpha. So there's two important pieces of information here. This equation of 5 cos beta minus 3 equals 0, that is important. This is important. Beta is between 0 to 90. What that means is that beta is within quadrant 1. If you remember when we first started our session, we mentioned that quadrant 1 is from 0 to 90, quadrant 2 is from 90 to 180, and quadrant 3 is from 180 to 270, and lastly, quadrant 4 is from 270 to 360. So based on that, if you knew your cost diagram, automatically you would have been able to see that beta is within quadrant 1. Now, if you look at alpha, you can see that alpha is also within quadrant 1 because it is from 0 to 90. Okay, now the other important piece of information is this equation over here. Alpha plus beta equals 90. So you've got two important equations that you need to make use of in order to calculate cot alpha. This is what we need to find. We need to find what is cot alpha equal to. Okay, keeping in mind that cot is a reciprocal, meaning that it is 1 over tan. Okay, so let us use that information to try and find an answer. Let's just get a space that we can use to work in. Okay, so let us work over here. Now, this is question 4.5. Okay, this is question 4.5. Now, question 4.5, let us write down the important information that we were given so we do not forget. We were told that beta is from 0 to 90, meaning that it is within the first quadrant. In addition to that, we were given the equation 5 cos beta minus 3 equals 0. So that's the first piece of important information. The second was the equation that we were given with alpha and beta. Now we were told that alpha plus beta is equal to 90 degrees. We were then told that alpha is within the first quadrant. So all of that is important. And lastly, we need to find what is cos alpha, or rather cot alpha equal to. So what we are first going to do is we are going to draw a triangle that is within the first quadrant, because we were told that everything is within the first quadrant. So our triangle now needs to be within the first quadrant. If we were told that this angle is in the second quadrant or the third or the fourth, we would have drawn it in that respective quadrant. So we've got our triangle. We'll have this as beta. Now, let us solve for this equation. In order for us to find out what is our hypotenuse, what is our adjacent, and what is our opposite, we need to solve for this particular equation. So we've got 5 cos beta minus 3 equals 0. All we need to do is move the 3 to the other side. It will then become positive 3. From there, we can divide both sides by 5, and we then finally have cos beta equals 5 over 3. Keeping in mind that cos is equal to the adjacent over the hypotenuse. So we now have the adjacent and we have the hypotenuse value. So if we go to our triangle, we know that this is the hypotenuse. We know that this is the adjacent and this is our opposite. So this is then going to be adjacent, which is 3, hypotenuse, which is 5. We now need to find the opposite side. Using Pythagoras, we will be able to find that opposite side. So let us do this on the side. I know it seems kind of long, but please don't forget the actual question. We need to solve for cot alpha. That is what we are trying to do. This is our question. We need to find the value of cot alpha. Okay, so let's use Pythagoras on the side. We've got hypotenuse squared equals the adjacent squared plus the opposite squared. This is our theorem of Pythagoras. Now, we know that our hypotenuse is 5, so we can substitute 5 squared. We know our adjacent is 3, so we can substitute 3 squared, and our opposite is the unknown value. That's what we need to find. So from here, we can move that 3 squared to the other side, so we only have our opposite on this side. So that is then going to be, let's see, 5 squared is going to give us 25. 3 squared is going to give us 9. So 25 minus 9 will give us 16, and that is our opposite squared. From here, all we now need to do is square root both sides. So once we square root both sides, we will end up with plus or minus 4, because the square root of 16 is 4. Now, how do we know whether we are supposed to use the positive 4 or the negative 4? What tells us that? It's your position of your y or your x value, or your position of your opposite or your adjacent, whatever you are calculating. So if your opposite is on top, meaning the positive y area, you will choose the positive 4 value. If your opposite was in the negative y area, the bottom, you would have chose the negative 4 value. If we were calculating the adjacent and our adjacent was on the right, we would use the positive value. If our adjacent was on the left, we would use the negative value. So keep that in mind. You have to use the correct sign. You can't just go choose any sign. If you're on the positive x side, use the positive x value. If you're on the negative x side, use the negative x value, okay? So we are going to take positive because our opposite is in the positive y area. So we are taking positive 4. So this is going to now be positive 4. Okay. Now, we've completed our triangle. We have the adjacent, we have the opposite, we have the hypotenuse, and we've labeled all of our sides. Now, we've used the information on the left. We've not yet used that equation of alpha plus beta equals to 90. So let us use that. Something important, if you remember what we did previously, you should already know why we are using that alpha plus beta equals 90. If you think back to I think it was the first question that we did, 4.1.1c, where we dealt with the three interior angles of our triangle. You'll see that alpha plus beta equals 90 represents this angle on top here. Remember what I said earlier? That angle on top just represents 90 minus theta. In this particular case, it will be 90 minus beta. So let us solve for this angle. So let us solve. Now we've got alpha plus beta equals 90. If we want to solve for alpha, we want to get the value of alpha. We'll take everything to the other side. In this particular case, beta, we'll take beta to the other side. And this is now our equation of alpha. Alpha is equal to 90 minus beta, and that is the angle over here. So this is alpha. Okay, and keep in mind that alpha is 90 minus beta. Okay, if you want to add all three interior angles of the triangle up, meaning that if you want to add beta plus the 90 plus the unknown angle, as we did in question 4.1.1, you would still arrive at 90 minus beta. So that is the proof that that angle on top is in fact alpha. Okay. So we've used up all of the information that we were given. Now let us have a look at the question itself, keeping in mind that our question is to calculate cot alpha. So what is cot alpha equal to? We know that it's a reciprocal, but what is it equal to? So let us investigate that. We know that the reciprocal of tan is cot alpha. The reciprocal of cos is sec. The reciprocal of sine is cosec. So we now know that cot alpha is going to be equal to 1 over tan alpha. So we need to find what is 1 over tan alpha equal to. So from here you put your 1 over. We know that tan alpha is opposite over adjacent. So let us make some space. So that is what we have, right? Tan alpha is equal to opposite over adjacent. Now we need to find what is the opposite value, what is the adjacent value? Because keep in mind, we are using alpha now, so it's not going to be the same. Previously, we were using beta. That's how we ended up with 5 as the hypotenuse, 3 as the adjacent, and 4 as the opposite. In this particular case, we are now using alpha, which means we have a new reference point, meaning that we are going to have a new opposite and a new adjacent, okay? So please keep that in mind. That's extremely important. So let us try to redraw this thing quickly. Actually, to save time, let us just write it on that diagram. So I'll write it in white. So this will be our new opposite, and in brackets I'll put alpha so we know which we are referencing. This will be our new adjacent, and in brackets I'll put alpha so you know which it is for. Let's do the same thing with the blue. So we know this is for beta. We know this is the adjacent of beta. Okay, now we've now located which is the adjacent, which is the opposite, and which is the hypotenuse. Keep in mind the hypotenuse stays the same. It's for alpha and it's for beta, okay? So we now have our opposite, our adjacent, and our hypotenuse of alpha. Now let's substitute. So from here we can substitute 1 over. Now opposite, our opposite is the white one, the white handwriting. Keep that in mind because we are using alpha as a reference point. So our white handwriting opposite is 3 over our adjacent. Once again, look at the white handwriting because we are using alpha as the reference point. Our adjacent is going to be 4. Now, if you put this into your calculator, you'll end up with the value of 4 over 3. Okay, so if you don't want to put it into a calculator, if you want to try and remember how to use division, it's just 1 divided by 3 over 4. And you swap this, so it becomes 1 times 4 over 3, which becomes 4 over 3. Okay, so that's an alternative method that you can use if you don't have access to a calculator or if you don't want to use your calculator. Okay, so our answer of cot alpha is 4 over 3. Now I understand that this was quite a long question, so we'll go back, we'll do a quick recap, and then I'll give you the opportunity to ask any questions if you have anything that you want me to repeat, something that was not clear, or something that did not make sense. Okay, so let us zoom out and recap the question. So question 4.5, right? We were told that we needed to find the value of cot alpha given the 4 pieces of information. One of those pieces were 5 cos beta minus 3 equals 0. And accompanying that piece of information, we were told that beta is within quadrant 1, being between 0 to 90 degrees. Secondly, we have the second piece of information, which was alpha plus beta equals 90. And accompanying that piece of information, we had alpha in quadrant 1, meaning that alpha is between 0 to 90. Our first step was to solve that equation. Whenever you were given an identity or a trig equation, always solve it to have sine of that angle equal to something, cos of that angle equal to something, or tan of that angle equal to something. Don't ever leave it in that equation form unsimplified. Always simplify to solve for your identity. Now, once you were done solving for that, we then ended up with cos of beta equals to 3 over 5. Now, from there, we then know that cos is equal to the adjacent over the hypotenuse. So we were then able to find what is our what is our adjacent and what is our hypotenuse of our particular triangle. Now, from there, because we were missing our opposite, we then used Pythagoras to find it. Once we used Pythagoras to find it, we ended up with the issue of, is our value of our opposite positive or is it negative? So in order for us to figure that out, we needed to know that when we are dealing with a y value, when we are dealing with an opposite, if our height of our triangle is in the positive y area, we choose the positive value, meaning that if our triangle is in quadrant 1 and quadrant 2, we are going to use the positive y value. If our triangle is in quadrant 3 and quadrant 4, we are going to use the negative y value. Okay, now if we are dealing with x, let's say we had the opposite, but what we were calculating for was the adjacent. Okay, so if we are calculating for the adjacent, if our triangle is on the right, we use the positive x. If our triangle is on the left, we use negative x. Please keep that in mind, it's important. If you don't understand what I'm talking about, when I release the recording or the screenshots, I would recommend you go and have a look at the proof, okay? That'll be easier. Now, once we found our value of our opposite, once we found that positive 4 value, we were then able to start solving for the question. So if you notice, there was a lot of work that we needed to do beforehand, before we actually got to our question. Our question was to find the value of cot alpha. So once we found all of that information, once we completed our triangle, we were then able to find the value of cot alpha. And in order for us to do this, we needed to know that cot is a reciprocal of tan. And what is tan equal to? Tan is equal to the opposite over the adjacent. Now, an alternative way of representing this would have been to, before you even substituted, would have just been to say, okay, 1 over opposite over adjacent, that is just adjacent over opposite, okay? That is an alternative approach that you could have taken. You didn't need to keep bringing down the 1 if you didn't want to, okay? That is an alternative approach that could have been taken. Now from there, once we were able to substitute, all you needed to do from that point was put this into your calculator, okay?